So this video is going to be looking at how we use this general term to help us with binomial expansion. In your formula sheet, you don't actually get given the general term explicitly, but our general term, which is this one here, is equal to, we are saying the term r plus 1, so if you say I want term 3, then r would represent 2 in that, because 2 plus 1 would make term 3. So term 3 would be equal to this n on r, where n is actually the power that is associated to your binomial expansion. So n is this value here, and you can see n is the same in your formula sheet. Rather than using a plus b in the formula sheet, they use x plus y. I've been using a plus b because it generally is less confusing, because you usually have x and y's in the binomial expansion, but it is exactly the same. So this general term then will help us find the value of a particular term. So if I said I want you to tell me what the 5th term in this binomial expansion is, or the 7th term, in order to do that then we need to know the value of the r, the n, and the a and the b. That's how we find the term. So all those values, where they come from, and this n on r we'll talk about in a moment. The n is always the power that is on your binomial expansion. The r is representing sort of which term you're looking at, but remember, if you're looking at term 3, then your r value will be 2, because it's r plus 1 is how we work this out. So term 3 is 2 plus 1, so r is 2 in this case. And your a and b values are found by whatever your binomial expansion is. Now, like I said, this general term actually isn't explicitly given in your formula sheet, but you can actually see that it is located here in the expression you do get given. So this is n on r. Instead of a, they use x to the power of n take r, and instead of b, they use y to the power of r. So it's all the same. And we can use this, like I said, to locate a particular term within this. Now, the other key crucial bit is this n on r. Now, this is basically how you find those coefficients, or those values from Pascal's triangle on your calculator. This representation of n on r in brackets is saying that you are using this NCR button on your calculator. It's written like this in your calculator, and this means you are doing n choose r, and the maths behind it comes from the Pascal's triangle. So when we look at a calculator, I'll just bring mine across here, to find this NCR button, it is not located in any of these places. What we need to do is hit the option button, and this is all in statistics and probability. So it's not found in statistics, it's actually found in prob, for probability, F3. And here you can see there is that NCR. So when you enter in something for NCR, so for example, we have been using, let's say, if we think about Pascal's triangle and we think about row 3 or something, which goes 1, 3, 3, 1, that's row 3. Row 4 will be 1, 4, 6, 4, 1. So this is the 3rd row, this is the 4th row. We can use the calculator to do this. So if I was using, let's look at the 4th row, then to find this value, what I do is I type in 4C0. This one will be 4C1, 4C2, 4C3, 4C4. So if we type those in on our calculator, they don't put them in for the first and last term in your formula sheet, and this would be n on 0 and n on n essentially at the end here. But like I said, they don't do that because it always comes, the edge of Pascal's triangle is always 1. But if we were to do that, so if we were to do 4C0 and press enter, it gives us 1, 4C1 equals 4, 4C2 equals 6, and then we can see if we keep going through this, we end up with Pascal's triangle coefficients. And this works for any row. So if you wanted to do row 5, you do 5C0, 5C1, 5C2, 5C3, 5C4, row 6, 6C0, and so on and so forth. So depending on which value of Pascal, which line on Pascal's triangle you want, that's the number you put first in when you're entering these 4C somethings. So that's how your calculator is going to help you. Now, this general form, how is it useful? Let's have a quick look at a couple last examples. So this one here is asking us to basically, rather than writing out 12 lines of Pascal's triangle, let's now use that NCR button on a calculator to work this out. So we need to write down the first 3 and the last 2 terms of this expansion. So the first term then, remember, if it's Pascal's triangle and we have a power of 12, then that means my first term will be 12C0, and we can write that as 12 on 0. And remember that this then will be a to the power of 12, that first term to the power of 12, but b will be to the power of 0. And then we're going to add on 12C1, a to the 11, b to the power of 1, plus 12C2, a to the 10, b squared. And that will be our first 3 terms. Our last 2 terms are going to be when we have 12 choose 11, because that would be 1 before, and a will be to the power of 1 and b now will be to the power of 11 because it will go up to 12, and our last term will be 12 choose 12, and it will be b to the power of 12 because a will be to the power of 0. Now in our case, a is equal to 2x, b is equal to 1 on x. So we can actually work this through, and if you type in 12C0 on your calculator and then 12C1 and so on and so forth, you actually get the following. So we'll get 12,0, a is going to be 2x to the power of 12, plus 12 choose 1, a again, b is 1 on x, plus 12 choose 2, a, and b, which is 1 on x, plus, and we'll kind of have to carry this on the line below, I reckon. So this will be 12 choose 11, 2x to the power of 1, b now to the power of 11, plus 12 choose 12, b to the power of 12. And remember, the power should always add up back to the power on the expansion. And if you actually type all these values in, so if you do 2 to the power of 12 and then times it by 12C0, you end up with 4096 x to the 12. I would like you to pause and have a go at that if you can. 2 to the power of 11 in times 12, C1 is going to make 24,576 x to the 10. And if you keep doing this, you should get these values. And we'll have some terms in between we don't need to worry about. 24 on x to the 10 plus 1 on x to the 12. So that would be our expansion. Looking at another example then, so this is where, so this, I guess just one more thing to add to this one. Using this and finding first 3 and last 2 terms is using this format here that we get given in our exam, and that is exactly what we're using to do that one. For this next one though, we get asked to find the coefficient of the x to the power of 10 in this particular expansion. Now x to the power of 10, we don't really know where this occurs in this expansion. Might be able to make some assumptions, but particularly when it gets to more complex ones like this next example after, it's hard to locate where the 6th term would actually occur in the expansion. So what we're going to do is just say, well, we know it's going to occur at a particular point. So we can say, well, this generic term, which is going to be 1 plus r, because remember the term is always 1 more than the r value. If we go back to this one, r plus 1, is equal to n on r, and then we multiply that by, I'm going to use a's, you can use x's like the exam formula, b to the r. So that's just taking that term from that formula sheet. Now what we want to do here is, we know from our particular question n is equal to 10. We also know that a is equal to 3 and b is equal to 2x squared. So we can put all this in and we can say, and we are basically just trying to find out what the value of r is for this. So we're going to have 10 on r times a, which is 3 to the power of n, which was 10, times b, which is 2x squared to the power of r. So I'm trying to find out basically what value r would take so that we get an x to the power of 10. So I need to isolate x's, that's what I need to do. So I'm going to be rearranging without moving over the equal sign, and there's 3 to the 10 take r, there's no x's in that, so I don't need to do anything with that. But this 2x squared, I need to separate this so that I just get my x's and my 2 is no longer attached to it. So I'm going to rewrite this as 2 to the power of r times x to the power of 2r. Now we've isolated our x, so all this part here, this section here is all just going to give you the coefficient essentially. It's just numbers, there's no x's in that term. So what we know is that this is where our x to the 10 is going to come from. So what we can do is we can say, well, x to the 2r must equal x to the 10, so that we can find out, well, what value of r would this equate to? So the value of r that this would lead to is actually when r is equal to 5, because 2r equals 10 and r equals 5. What we do now is we put that back in. So we can then say, okay, if r has got to be 5 in this case, then if we substitute that in, we can find the coefficient. So we get 10 choose 5 times 3 to the 10 take 5 times 2 to the power of 5 times x to the power of 2 times 5, which is 10. So this green section, if we type it all in on our calculator, that will actually give me the coefficient of x to the power of 10. So if we type that all in on our calculator, we actually end up with the following. And this here is my coefficient of x to the power of 10. This example is a little bit harder, but the principles are still the same. So we're going to have term r plus 1 is equal to n on r, a to the power of n take r, and b to the r. And in this case, our n value is 12. We can see that from the question because the power is 12. Our a value is x squared and our b value is 4 on x. And from this, we can then say we are looking for what is the coefficient of x to the power of 6. So x to the power of 6, what we want to do is the same thing we did in the last one. So I'm going to start putting values in. So I get 12r a, which is x squared, to the power of n take r. So that's a 12. Times b. And again, to figure out, basically in this expansion, we're trying to say, well, when I sub in a particular value of r, what value will end up with this all coming back together to give me a power of 6 on my x term. So I need to collate all my x's together, because at the moment they're in 2 separate places, and find out what value of r will mean that this spits out an x to the power of 6. So collating this all together, I'm going to expand the power, so I multiply this one, so that'll be 24 take away 2r. And I'm just going to distribute this one to both terms. So this will be times 4 to the r and x to the r. I'm going to rewrite that second one. And we can rewrite this as 4 to the r times x to the negative r, bring the power to the top. And I'm now just going to bring all the constants together. So this 4 to the r is not going to produce any x term. And then I'm going to put all my x's together. So I get 24. If I have 24 take 2r times x to the negative r, a times means I add the powers, so negative 2r add negative r means negative 3 lots of r. So I now have my x all on its own here. And what I want to do with this is I want to say, okay, what particular value of r will mean that this term here will now actually just say x to the power of 6. So what I want to do is say, what value will this make x to the 6? And we're going to equate our powers to do that. And if I subtract 24, I get negative 18 equals negative 3r. Dividing by negative 3, I get 6 equals r. So when r is 6, if I was to substitute that into here, this would spit out an x to the power of 6, which is what I needed to happen. So to find now the coefficient of that term, I now need to substitute that 6 value into the full equation. So I get 12 choose 6 times 4 to the power of 6 times my x to the power of 24, take away 3 times 6, which will make that now a power of 6 on the x. So I get 12 choose 6, 4 to the 6, x to the 6. And if you type in the 12 choose 6 times 4 to the 6 on your calculator, so let's do that one together. So if I go in here and type in 12 choose 6 times 4 to the power of 6, I get an answer here, and that is my coefficient. So it was 3, 7, 8, 4, 7, 0, 4, x to the 6. So that is the coefficient. And if we were to do this final problem, which actually asks you to find the constant term, what we do with this particular one is we actually say, instead of letting that equation equal x to the 6, we want this to equal x to the 0, because that's when a constant term, there's no x there. So what we do is a bit like in this part here, we let x to the 6 equal 24, take 3r. We're actually just going to let x to the 0 equal x to the power of 24 minus 3r. And we're going to equate the powers and solve now. And I will get 3r equals 24, so r equals 8. And so this will be the particular value of r that will give me the constant term. So I'm going to put that into this expression here, because that is my sort of general form for a term. And it will give me 12 on 8, so 12 choose 8, times by 4 to the power of 8. And this will be times x to the power of 0, so that's why it will give me the constant. And again, just typing this in on the calculator, we get 12 choose 8 times 4 to the power of 8, and this here will be my answer. So 3244, so it's 32440, 320. And that will be the constant term.